All right, so good evening once again, students. So from the last class, unfortunately, I got kicked offline by a power cut, and then now, I didn't get to finish up as I would love to. But let us pick up from here and move on. So from the previous class, we were talking about class limits. And anybody would like to tell me what, give me a recap of what you learned from the previous class? Ms. Clark, you want to go ahead?
Awesome.
Let me call on Miss Waysome. Miss Waysome, give me a recap of what we've been through the previous class.
Good evening, sir.
Good evening, Miss Waysome.
From last class, sir, we looked at class boundaries. We have and class limits. So the limits of a class, you have the lower limit, and yes, you have two class limits. First limit and the second limit, sir, if I saw. And we looked at how we calculate upper boundary for a class. So for instance, the upper boundary for a class would be the upper boundary for that specific class added with the lower boundary of the following class divided by 2. And then we looked at the lower boundary, sir, which would be the lower boundary for that specific class added with the previous upper boundary of that class divided by 2. And we looked at class limit. No, not class limit, but the width.
Yes.
The width, sir, which would be minus taking away the first limit from the second limit to give you the answer for that. If you get what I'm saying, sir. We looked at all of that.
That wouldn't be for the width, The width the upper boundary minus the lower boundary. But the class midpoints, you would...
Yes, the class midpoint, sir.
Take away the lower class limit from you add the lower class limit and the upper class limits, and then divide by 2 to get the class midpoint.
How would you do the width again, sir? We never do the width.
The class width, you subtract the lower class boundary from the upper class boundary of that class.
Right, so that means, sir, the first one and the second one, and then again.
The class.
Okay.
Right.
Okay, sir.
All right, so we are going to just recap, and so that to give clarity to what we would have gone through in terms of the class. So first and foremost, remember, we use classes so that we can make it more convenient to represent very large amount of data, and so as to make it concise and clear. The class group we call it group distribution, where we have classes, is way more convenient than to just have the ordinary frequency distribution. So we are just getting to understand the various aspects of the classes. So we talk about class limits, which the limits of the class is simply the lower number and the upper number of the class. So the lower class limit for the first class would be 150, and the upper class limit would be 154. So we know the idea of limits, and we make a distinction between limits and boundaries. So we say, whereas the limits, the class limits where the class would end, but the boundary would tell you exactly where the two classes are separated, right? So we look at the limits to tell you where the class starts and where it ends, but the boundary would actually be the value between two consecutive classes where they have both limits close to each other. So it would be the value between the two limits. So for instance, the first class here have the upper limit of 154 and the second class have the lower limit of 155. So it means that the value between these two numbers, right? The value between 154 and 155 will give it a boundary. So all we need to do is to add these two values and divide by 2. Now, another way that you can do it is really to look at them closely and see how much they are different by. And if you notice that they're only different by 1, because you take away 154 from 155, the difference is 1. So you can just split that difference in 2. So you split the 1 in 2, you get 0.5. So you would add 0.5 to the smaller one. So you would have the class boundary for these two classes. So the upper class boundary for the first class would be 154.5. But the same boundary for the upper class boundary of the first class will also be the same boundary for the lower class boundary of the second class. So this class boundary share between the two of them, because remember now, it's like your fence line. So if this is a boundary separating the two properties, then it is your boundary. It is the boundary of the first class, and it's also the boundary of the second class. But based on the number, so the number for the first class would be the upper class limit, but the number for the second class would be the lower class limit. So it means that the same two classes in the boundary, both for the upper class and the lower class of the second class. All right. Any questions about what I've just explained? Is it clear enough? What I've just explained about the classes? Raise your hand for me, please. Anybody else have any doubts or confusion about what I was saying? Ms. Clark, is it clear enough for you?
Yes, sir.
Sir,
Mr. Paisley, how about you, sir?
sir, so at the first number, I first class and the second number, I second class.
No, man, it's not the first number. This is one whole class by itself. That's a class. This is another class. You follow Mr. Paisley? And this is another class. So the classes has to do with the range of the different range of values that you have listed here. So you have one range go from 150 to 154, the other range from 155 to 159, the other range from 160 to 164. Why do we have these classes? That is because by using these values in this way, it would prevent us from listing all the values, because instead of listing 150, then 151, 152, 153, and instead of listing all the numbers between this, we know that if we take it from 150 to 154 as a class, whatever number are between these two values would be in that class. You get what I'm saying, Mr. Paisley?
Yes, sir.
Right, but for each class, there is a boundary. And when I talk about a boundary is something that bounds you or separates you in terms of a fencing or a line. When you have a piece of land, they put a peg there and draw a line or mark a line and say, that is the line that separates the two property, right? Understand what I'm saying, Mr. Paisley?
Yes, sir.
Right, but if you put a block on top of the line and you middle the line with the block, you will realize that part of the block will come over on your side, part of the block go over on the other person's side. You get what I'm saying?
Yes, sir.
And the part of the block that you would meet on your side before you get to the boundary is what we refer to as the limit. So it's the same thing with this class. The number that you meet before you get between the two values would be the limit. So for this class, why it is called the limit? Because we don't have any other number outside these numbers that will fit in that class. The limit of this class is 150 and 154. Any number smaller than that or any number greater than that must go into another class. You follow what I'm saying?
Yes, sir.
But the boundary now would be the closest value between the two of them. So if you look at 154, which is where the first class ends, and you look at 155, which is where the second class ends, the middle number between them, between 154 and 155, that would be the boundary that separates the two classes. You get what I'm saying?
Yes, sir.
So in this case, if you look at the two numbers, they are only different by 1. So if you split the 1 in 2 and share it for the both classes, then the boundary value would be 154.5. Because when you split 1 in 2, you get 0.5. You follow what I'm saying?
Yes, sir.
All right, so that boundary would share for the first class. It also will be shared for the second class. But remember, each class has 2 boundaries, right? Like if you have 2 neighbors, you have one boundary on one side of your property that bound off one neighbor, the other boundary on the other side that bound off the other neighbor, right? And that's why we talk about the lower class boundary and the upper class boundary. Follow what I'm saying, Mr. Paisley?
Yes, sir.
All right, so for the first class, where you have the 154, whatever boundary you have between that and the second class, that would be the upper class boundary for the first class. You agree?
Yes, sir.
But if you look at the lower value for the first class, it will be 150, right?
Yes, sir.
And if you share the middle value between 150 and 149, what would you get?
1.
If you look at the difference between 149 and 150, the difference would be?
1.
And if you divide that 1 by 2, so divide it into 2 equal parts, what do you get?
0.5.
Right, so it means that you would add 0.5 to the 149, so the boundary value would just be 149.5. So this would have 149.5. Down here would have 154.5. Right? So this boundary value separates the first class and the second class. This boundary value separates the class above and the first class. So this value would be the lower class boundary for the first class, but it would be the upper class boundary for this class. Likewise, this value here, which is the 154.5, would be the upper class boundary for the first class, but it is also the lower class boundary for the second class. You get the idea, Mr. Paisley?
Yes, sir.
All right. All right. Everybody else, you got the picture? Guys, Mr. Long, you're understanding it quite clear, and Mr. Ojeno? Raise your hands, guys, if you're okay with what I've just explained. Mr. Locke? Mr. Locke? Are you hearing me? Are you good? Mr. Locke, you need to respond. All right, I'm going to be moving on. All right, now we talk about the class boundaries, we talk about the class limits, and we did talk about the class midpoint. So the class midpoint is midway between the two limits, right? So what is the middle number between the two limits? That would be the class midpoint. To find it, you add the two of them and divide it by 2 and you get the middle number. Another way that you could use to find the limits, you could actually look at the difference between the two of them. What is the difference when I take away the smaller one from the larger one? Ms. Wayson?
Sir, could you repeat?
What would be the difference for these two class limits here for the first class?
154 from one, that would be 4, sir.
Right, so the difference is 4. Now you could also find the class midpoint by finding the difference and splitting it and share it between the lower, you put half on the lower limit. So if you split the 4 into 2, or you divide it by 2, you get 2. So you will just add it to what? The lower class limit. So you will get 152, and that would give you the class midpoint. Everybody see that?
Repeat that, sir.
We say that apart from adding the 2 limits and divide it by 2 to get the class midpoint, another way that you could do it is to just find the difference between the 2 limits. So the first limit for the first class is 150. The upper limit would be 154. Look at the 2 numbers and see if you take away the smaller one from the larger one, what would you get? What would you get, Mr. Paisley?
4.
4. So we are saying that if you divide this 4 by 2, right, you get 2. You follow that, right?
Yes, sir.
Now, to get the class midpoint, you simply add the lower value plus the 2, and you get the class midpoint. So this would give you what? The class midpoint would be 152. You follow what I'm saying? So in the middle of this class, the middle value would be 152. That's all I'm saying, Mr. Paisley. You get it?
Yes, sir.
All right. Now, the same 2 that you add to the lower limit of the first class, you can add it to the lower limit of all the classes to get all of the midpoint for all of the classes. So what would be the midpoint for the second class, Mr. Paisley?